What do you got for starters?
Okay, so for starters, I have sine x, cotan x equals cosine x. And then I have to make a proof using this.
Right. Well, the typical way you do these is you work with a more complicated side and you
Yes.
turn it into the other side.
Okay.
Okay. What is the identity? And the only purpose of these, there's no practical application in the world for these other than one thing, and that is to get you to memorize your 11 basic trig identities.
Oh,
Okay? In other words, after you work a number of these problems, verifying trig equations, you'll be amazed at how much better you know your trig identities. I mean,
so it's like,
maybe
yeah,
you know them pretty good already, but what's cotangent equal to?
sine over cosine.
It's
Or cosine over sine, yeah, cosine over
cosine
sine.
over sine, okay? And that's critical here because now the signs cancel and we have cosine x,
Cosine x.
and that's all we need.
And then also for the proof, I also have to like name the type of step I use, like common denominator
What I
and things
did
like
was
that.
I substituted the quotient identity for cotangent x.
Okay, so substitution.
Uh-huh.
Okay. Because my teacher's super picky about that.
Well,
That's why.
yeah, I mean, I'm not sure what she's or he is looking for in terms of that, but it's always substitution. In other words, every single step you make when you're proving a trig identity is substituting an identity.
Okay.
Let's just talk about the 11 basic identities. Okay? The main three are those three.
Mm-hmm.
What's the reciprocal of sine?
Um, 1 over secant.
Okay, let's start with
The
tangent. What's the reciprocal of tangent?
the reciprocal of tangent is cosine over sine.
The reciprocal, not the quotient identity, but the reciprocal.
Oh, wouldn't it be cotan?
Yeah, 1 over cotan, which only leaves the other two trig functions. One goes with sine and the other goes with cosine. Well, cosecant
Yes.
goes with sine, secant goes with cosine. Notice that there is exactly one co in every pair.
Okay.
So as long as you know the reciprocal of tangent is 1 over cotangent, then you can't miss the other two.
Mm-hmm.
In other words, when you said sine was 1 over secant, can't be right. There's no co in there.
Okay.
Okay? And then, of course, the other three are just the reverses. In other words, if,
Flip it.
yeah, so that makes up your first six. Okay? Those are critical to know for verifying trig identities. There's
Okay.
two others that are pretty important, and these are the quotient identities. And you really only have to remember tangent. What's tangent?
Tangent is sine over cosine.
The only reason that's the only one you have to remember is because you know this is the reciprocal, so it has to be cosine over sine. Okay? So
Okay.
those are your two quotient identities, and there's only two. That's a total of 8. There's 3 more. And the 3 more are your Pythagorean identities. This being the most important one. What's cosine squared plus sine squared equal to?
Um, I'm guessing tan squared.
1.
X.
1.
Or 1. Okay.
1. Always 1. No matter what x is. X can be 30 degrees, x can be 45 degrees, x can be 390 degrees. Does not matter. If you take the sine of x, square it, add it to the cosine of x and square it, you'll always get 1. Okay?
Okay.
Now, that's the most important one. The next one is a little bit stranger doesn't quite fit the same pattern, but there's a 1 involved. Secant relates to, tangent squared relates to secant in that manner right there.
Okay.
Okay. Now, there's a third one, but you really don't have to remember it. The third one is the same as the second one, only using cofunctions. Okay, now by cofunction, I don't mean the 6 reciprocal. Even though there was exactly one co in each of those pairs, those are not cofunctions. These are not cofunctions. These are reciprocals. Okay? Cofunction is the function with a co in front of it. So the cofunction of sine is cosine. Cofunction of tangent is cotangent, same as reciprocal. Cofunction of secant is cosecant. And vice versa. The cofunction of cosine would be sine.
Okay.
Okay, so it's important to know your cofunctions. And in terms of this third Pythagorean identity, well, it's the cofunction of tangent. Well, that's cotangent plus 1. And what's the cofunction of secant?
Cosine.
Cosecant. Remember,
Cosecant.
cofunctions just take the function and stick a co in front of it. It's the easiest one to remember of all of them. Okay? And so these are your 3 Pythagorean identities. And these 11 identities, 6 reciprocal, 2 quotient, and 3 Pythagorean, will solve every trig verifying problem you have, unless it gets into sum and difference and things like that. But it looks like you're dealing with the basic ones. So what else do you have?
The next one I have is tan x sine x plus cosine x equals secant x.
Okay. Clearly the left side is the more complicated side. So we're going to work with it. Now, unless there's something pretty unusual about the equation, one of the good methods to try is to convert everything to sines and cosines and go from there.
Okay.
Okay, that's always they give you about 5 rules as to how to do these. And one of the rules is you can't treat it like an algebra equation. In other words, I can't divide both sides by secant x. Okay, that's one of the things you cannot do. And there's some special things you can do that you wouldn't normally do in solving an algebra equation. But if all else fails, switch everything to sines and cosines and go from there. So we haven't tried anything else, but I'm betting that that's the best way to solve this. I'm going to turn tangent into that because of the quotient substitution.
Okay.
Okay, what does that give me? That gives me sine squared x over cosine x plus cosine x. Now, what am I going to do with that expression there?
Couldn't we cross out?
Well, you can't really cross out, but you can add the 2 of them together. In other words, I've got to find a common denominator, though. What's my...
yes, to multiply it by cosine x.
Right. In other words, my common denominator is going to be cosine x, and in order to get that over there, I got to multiply top and bottom by cosine x to get that. Okay, I'm still working with just the left side, and now I have 2 fractions that I can add. By adding the numerator, going with the denominator. What's that numerator equal to based on the Pythagorean identity?
1. 1 equal 1.
So I've crossed it out and made it equal to 1. Now, what is one? There's kind of another tradition that mathematicians like when they're dealing with trig functions, and that is they don't like leaving a trig function in the denominator of a fraction, not if they can help it. So
Okay.
I'm going to turn that in to what would be the reciprocal of it.
Oh, the reciprocal would be secant.
Yeah. And that's what was on the right side all along. So that proves it. To me, that's all you need to prove it, is to make the left side look exactly like the right.
Oh, okay.
Okay? When she says prove it, I think that's what she means.
Okay.
It's not like a geometric proof. In other words, it's not like a two-column proof where you're proving two lines are perpendicular or something. When you're doing verifying trig equations, is all you have to do is work with the left side or one side. Doesn't have to be the left, it can be the right. And there's no real rules against working with the right. I could have turned that into 1 over cosine if I'd have wanted to. Might have made the problem a little easier. I would have seen what I was looking for. But I'm going to be very disciplined here and work only with the left. So
Okay.
if she wants more in the way of proof, well, that's just the quotient identity.
Okay.
That, turning that into 1, is the Pythagorean identity. And then turning 1 over cosine x into secant x is the reciprocal identity. So if she wants you to give reasons for each one of them, those would be the 3 reasons.
Yeah, that's exactly how she likes it.
Okay, cool. Usually I don't have to write anything, because if you follow the sequence of the problem, you can see what we did. In other words, we substituted that for tangent. And then I guess you have to make the statement that you have to find a least common denominator and add those 2 things to get the next line, and so forth and so on. But be as specific as you like. You know your teacher more than I do. I mean, I can explain the concept from going from one line to the next. All right, what else you got?
Okay, the next one is 1 minus sine squared x over cosine x equals cosine x.
What's that equal to? Based on what?
Would it be the Pythagorean identity?
Yes. What is it?
And
in other words, if sine squared plus cosine squared equals 1, what does 1 minus sine squared equal?
that would equal cosine.
Correct. And in all honesty, this is the way you're going to see it much more frequently than you will sine squared plus cosine squared.
Okay.
In other words, they're going to be a little tricky. You know what I'm saying?
Yeah, since it don't make it easy.
Yeah. In the last problem, we actually were looking at sine squared plus cosine squared. But I would say in 90% of your problems, you're going to be looking at 1 minus one of those. And one of the keys in doing verifying trig equations is to be able to substitute one term for 2. Well, we have 2 terms right there. We can substitute cosine squared for those 2 terms. Now, just straight division gives you cosine in the top.
And then I can cross out.
Yeah, in other words, once we've made the left look like the right, we're done.
Okay.
If you have to give a reason as to why cosine squared divided by cosine is equal to cosine,
Substitution?
no, just division.
Just division?
Yeah,
Okay.
in other words, I don't really like having to support that. That's like saying,
Okay.
give a reason why that is equal to that.
Uh-huh.
It's division. When you're dividing same base, different exponents, you subtract the exponents. So I suppose you could say rule of exponents, but I can't imagine she wants you to do that.
Yeah.
Maybe you know her better than I do, but as I said, I've been doing these for 7 years, and the only thing you really need to prove is to make sure that your identities are correct, that you substitute. In other words, I had to make sure that I substituted cosine squared for that. Once
Okay.
I did that, I'm basically done with the problem because that's what I'm looking at. And now straight division produces that. And what I always do is once I make the left look like the right, I do that.
Okay.
Okay? All right. What else? These are fairly simple.
Yeah. Now that you're helping me, it makes it seem a lot easier in class. It seems completely.
Yeah, well, Trig is like a foreign language, and you're learning all of these things in a foreign language, which makes them more difficult to memorize.
Yeah.
But truly, the key is to memorize those 11 that I went over. If you get
Okay.
to the point where you know those by heart, then most of these verifying will come pretty easy.
Okay. So
There,
the next.
there's a couple of unusual ones that you have to do some strange things to that you wouldn't normally think of. Like, do you have any that's got either that expression or that expression or this expression or that expression?
I have the ones on the top two, but I haven't seen
Okay.
any at the bottom.
Let's do at least one of these. Even if you have to skip, we got more than 30 minutes, but I want to show you the special technique you do to handle these kind of problems.
Okay.
So let's do the one that's got that 1 minus sine or 1 minus cosine.
Okay.
Go ahead and read it to me.
Okay. So 1 second. I need to find another one real quick.
In other words, with the first couple of problems we did, is all we did was substitute.
Okay.
This is a different thing, that we have to do something other than substitute.
Okay, I found one.
Okay?
1 minus sine squared x.
Well, that's a little different. That's 1 minus sine squared. I'm going to be able to substitute cosine squared for that.
Oh, well then I don't have any of the other types.
You don't have any of the others?
No.
A particular one that I would be thinking of would be, let's simplify that expression. Okay?
Okay.
One way, the thing you normally do when you run up against that is you multiply by the conjugate, top and bottom. In other words, as long as I multiply top and bottom, I'm multiplying that fraction by the number 1, and I can do it. And this isn't something you might normally think of, but the reason it's so effective is because it produces 1 minus sine squared in the top. Okay?
Okay.
Notice what happens in the bottom. I'm not going to distribute that because the top now becomes cosine squared x. The bottom still has that cosine x in it.
They can cross out.
Yeah, if I'd have distributed it, I would have ruined the plan. So you don't ever distribute. And now the answer is that is the same as cosine x over 1 plus sine x.
Okay.
And we
That's
got
cool.
there by doing this multiplying by the conjugate.
Okay.
You may not have any that are that degree of difficulty, so we may not have to go there. But you may get there tomorrow or the next day where you would have some, so it's not going to hurt you to know that technique.
Okay.
What others do you have? The best way to do this is really to focus on the problems you have.
Okay. Secant x over cosecant x equals tan x.
Okay. Again, probably the best thing we can do is to switch everything to sines and cosines.
So it'd be cosine over sine equals tan x.
That's what we'll get to eventually, but you don't get there directly. What is secant x equal to?
Secant x is equal to 1 over cosine.
And what is cosecant x equal to?
1 over sine.
Now, how do I do that division?
I have no idea.
Flip the bottom and multiply, just like dividing fractions. I'm dividing 2/3 by 3/4. That's not a division problem to me. That's a multiplication problem. That's the same as 2/3 times 4/3.
Oh, okay. So reciprocal to multiply.
Exactly. And that's the way we're going to do all of these with trig. Because you frequently are going to have a fraction in your numerator and a fraction in your denominator. So when I reciprocate the bottom and multiply, I get
Sine over cosine.
And now using our quotient identity,
Makes tangent.
and that's what we're trying to do.
Okay, that's not that bad.
Now, all of the ones you've given me so far is all you needed was the reciprocal identities, the quotient identities, and the Pythagorean identities. Those 11. We'll do all of these. And so far, you haven't needed any tricks. In other words, we could do every single one of these by turning everything into sines and cosines.
Mm-hmm.
And that isn't always the best way to go. In other words, if I had, suppose I had something like this. Well, I already have a lot of sines and cosines, right? So it might make sense to turn this secant squared into 1 over cosine squared. But that would be the long way to go. And remember that with these verifying, there's more than one way to do it. There's an optimum way to do them, meaning in the shortest number of steps, and then there's any old way, which could be 10 times as many steps. And some of these get pretty difficult, so that if you happen to start off in the wrong path, you kind of get lost in the trees and you never get there, and you have to kind of go back and start from scratch. Well, the simplest thing to do here is to substitute tan squared for that, using the quotient identity.
Okay.
And now, that's equal to secant squared. So in 2 steps, I've got it solved.
Okay, I see.
And it did not involve converting everything to sines and cosines. This would have been much harder to prove if I'd have done that. Just for example, it would be sine squared over cosine squared. Got to turn that into cosine squared over cosine squared. And now I've got a common denominator, so I can turn this into 1 over cosine squared. And then using the reciprocal identity, that's equal to secant squared. So I get there, but I get there in one more step.
Yes. Like, that's how the way the teacher would probably make us do it, because she likes the most steps, no matter what.
Well, when you're doing verifying trig identities, you really want the least steps. It's like solving a Rubik's Cube. Would you rather solve it in 80 moves or 11 moves?
11 for sure.
Exactly. Yeah, same thing with verifying trig identities. It's not absolutely vital. In other words, you don't want to spend a whole lot of mental energy figuring out how to do it in 3 moves instead of 4, but just know that the faster way is the better way.
Okay.
The faster way in this case was to turn that into tan squared and then just use the Pythagorean identity.
Okay.
Actually, 2 steps instead of 4. So, what else, Taylor?
Okay. Sine x minus sine x cosine squared x equals sine squared or sine cubed x.
Okay.
So could I cancel out a sine using parentheses?
Well, you can factor out a sine.
Okay.
That's the thing you want to do. In other words, I can't really see too much else I could do here other than factoring out a sine. Factoring out something is frequently something you're going to want to do on these. If I factor out a sine, what am I left with?
Then it's just cosine squared.
Hold on. When you factor out something, you then divide that into each term, and whatever you're left with is what goes in the parentheses.
Okay.
So it's 1 there, because sine x divided by sine x is 1, minus cosine squared. And I'm going to suggest that when you factor out something, as you go, check to make sure you've done it right. In other words, the moment I write that 1 in there, I'm multiplying that times 1 to make sure I got that term right there.
Okay.
The moment I write in minus cosine squared of x, I'm multiplying that by that to make sure I've got that term right there. In other words, it's better to check as you go along than at the very end of the problem when you come up with, say, the wrong sign, and now you got to figure out where you made your mistake. Much easier to pick up mistakes as you make them. And everybody makes mistakes. So you're going to make your share of mistakes, but if you check as you go, you'll pick them up easier. Now what can I substitute for 1 minus cosine squared?
Would it be sine?
Sine squared x, the Pythagorean identity.
Okay.
Multiply those two together, you get sine cubed of x.
So I just always do Pythagorean identities at the end pretty much?
It depends on, we had one problem where we had to use the reciprocal identity, we had to use the quotient identity, and we had to use the Pythagorean identity. So it depends on what's called for. The only one, this is if your teacher is going to make you state words, then you're factoring on that first step.
Okay.
Second step, you're using the Pythagorean identity.
Okay.
The third step, you're just multiplying them together.
Okay. So far I'm picking it up very well.
What's that?
I said so far I'm picking this stuff up.
Yeah, so far we've been able to pretty much just put everything in sine and cosine and go from there. And that will usually work. It's not always the most efficient way, but if that's the only way you can think of to do it that way.
Okay. So the next one is sine x over cosine x plus cosine x over sine x equals secant x and cosecant x.
Okay. It's tempting to turn that into tangent and cotangent.
Yes.
But that wouldn't get us close to that.
Since wouldn't I have to keep it in sine and cosine?
I would, because for one thing, looking at that, I can tell, well, that's the reciprocal of sine, or rather cosine, and that's the reciprocal of sine. So the right side is actually this. Now, I'm not going to fool with the right side, but I'm going to look to the left side to get what I've got circled there. If I can make the left side say what I've got circled, then it's one more step to turn it into secant x, cosecant x. With me?
Okay.
Okay.
Yeah.
Normally, when you have fractions, the right way to proceed is to add the fractions. Okay, what's the common denominator?
It would have to be. They wouldn't have to multiply both sides.
Right. So there's the common denominator. What goes up here?
Sine
Yep.
x.
And before you go any further, let's check to make sure we haven't changed anything. In other words, is that the same as that? It needs to be. And it's not.
No.
So what do I need to add? I need to add a sine squared right there.
Since it multiplies. Okay. So whatever you do to the bottom, you do to the top.
Exactly. In other words, you're never changing these fractions. You may make them look a little different, but they can't be changed. Whenever you're finding a common denominator, you got to make sure that the two fractions you come up with are the same as what you started with. And so far,
Okay.
this one is this one. Now, what's got to go over here to make that equal that?
Cosine squared.
Exactly. And now, what can I substitute in the top?
Wouldn't it? Couldn't you cross?
What's sine? You don't want to, though. What's sine squared plus cosine squared?
Oh yeah, that's one. That's one. Yeah, that's
Exactly. Whenever I can take two terms and replace them with one, I almost always want to do that.
one. Okay.
Okay? That's what I was looking to produce, was that. So now the next step, in other words, I don't want to fool with the right side, but I can certainly turn that into secant x, cosecant x. And that is the same as what we started with.
Without you having to do the extra step on the left side.
Yeah, you do have to do that because you have to end up with exactly what's on the other side.
Mm-hmm.
So if I'm looking for reasons here, I'm adding two fractions using a common denominator to get the second step. To get the third step, I'm using the Pythagorean identity to replace sine squared plus cosine squared with the number 1. And the third step is using the reciprocal identities. Notice that this is the same as 1 over cosine times 1 over sine. And that's the same as secant, and that's the same as cosecant. So I can go directly to that. I don't really need to do this. I was just explaining that in case you were having any questions about it.
Oh, okay.
Okay?
1 second.
If you have any harder ones, we got about 20 minutes. Usually the student directs because you know how many problems you want to cover, and maybe you've got 45 minutes worth of problems still to cover, which means you've got to pick and choose and do some that you're not quite sure how to do.
Okay, so I'll do parenthesis secant x plus tan x close parenthesis open parenthesis secant x minus tan x close parenthesis equals 1.
Okay. whenever you see the difference of perfect squares factored, okay, let's talk algebra. X minus 1 is always x minus 1 times x plus 1. Remember difference of perfect squares?
Yes.
Okay. Well, you usually are going the other way with trig. In other words, you usually see it like that. And so multiplying them back together again is going to give you secant squared minus tan squared. And it's just a good thing to memorize because otherwise you would have to FOIL those. Or is that a word you're familiar with, FOIL?
Yes.
Okay. You could FOIL these, but every time you FOIL something that is a minus b times a plus b, you get a squared minus b squared. So you can save yourself a lot of time by recognizing it and knowing that that's got to be secant squared of x minus tan squared of x. Okay.
Okay.
Now, what is the trig identity involving tan and secant?
Well, let me think. Tan and secant. Doesn't that equal?
Plus 1. That's what it is right there.
Okay.
Okay. So, secant squared minus tan squared is equal to 1 based on the trig identity. If you, I guess I can make it look a little prettier by doing this. Secant squared of x minus, and instead of tan squared of x, I'm going to write that. Whoops, excuse me. Can't even do that. In other words, my problem is this explanation to your teacher that you have to give.
Okay.
I can substitute for secant squared. That's what I meant to do. Okay, secant squared is equal to that. So I'm going to substitute the Pythagorean identity for secant squared. And then I'm going to subtract. Okay, so that was just substituting the Pythagorean identity. Now when you remove the parentheses and subtract, you get 1.
Okay. And then I don't have to go through the other steps you were showing?
No, I don't think so. In other words, this is multiplication. This is Pythagorean identity. Substituting tan squared x plus 1 for secant squared x. And then once you've done that, and then this is just addition. In other words, addition and subtraction.
Okay.
Hands go away. And you're left with just 1.
Okay. Can you hear you?
Hi.
Hi, how are you?
I'm good.
How about you? Is this Carissa?
It is. Yes. I made it home.
If you need more time, if you guys need more time, and if it's okay on your schedule, just let me know. I can always put more money on the account.
Okay. First of all, Carissa, let me tell you, I do offer the first half hour free.
Okay.
And since you paid $40, you've got another half hour. In other words, if we end the session tonight at 10:30 your time, then you've got a half hour coming. So you can either schedule a half hour session and I won't charge anything next time for it, or if you want to do an hour session, just pay me. And it's in fact you got more than that because my rate is $32 per hour.
Oh, okay.
It was $40 an hour if it was in person, but if it's online, it's only $32. So you actually have you're entitled to 16 for free. So you have a $24 credit at the end of tonight.
Okay. All right. Sounds good. Thank you so much.
You're welcome.
All right. Well, I'll get out of here. I'll step back out and let you guys finish up.
Okay.
Okay.
So,
Thank you.
All right, Taylor, what else you got?
cosecant x minus sine x over cosecant x equals cosine squared x.
Like this?
Yes.
Okay.
So,
What did I do to the left side? Did I write the left side correct?
yes, perfect.
As long as the denominator is a single term. In other words, if I have a plus b over c, that is equal to a over c plus b over c. Okay?
Okay.
If I have a over b plus c, I cannot break it up. That is not equal to a over b plus a over c. So the only time you can break it up into two fractions is if you have a single entity in the bottom.
Okay.
Okay, so I'm going to break this up into this minus this. Step one. Okay?
Okay.
Now, that's equal to 1. And this, I'm going to make it sine x over the reciprocal of cosecant, which is 1 over sine. Like that.
Okay.
Now flip and multiply, and what do you get?
Okay, so then it would be sine over 1 times sine over 1, and that would be sine x squared.
Sine squared of x. And in that, use the Pythagorean identity to substitute cosine squared of x, which is what we were trying to prove.
Okay.
Okay, let's talk about one thing first. There is a difference between this and this. These are not the same things.
Okay.
This means sine x times sine x. This means you square the x first and then you take the sine of it. So these are completely different things.
Okay.
Okay? The only reason I mentioned it is because,
Yeah, I said it just now.
yeah, it looked like you maybe confused it for a moment. Okay, what else you got?
Okay. I have sine over cosine x plus cosine x over 1 plus sine x equals secant x.
All right. Well, remember what I said about when you run into stuff that looks like that?
Yes.
You're not going to be able to use the Pythagorean identity on it because nothing's squared.
Mm-hmm.
But if we multiply top and bottom of this second term only by 1 minus sine x, we will end up with a 1 minus sine squared x in the bottom. That's useful because we can then substitute cosine squared for that. Okay, so here's what I'm going to do. I'm going to take that term only, and I'm going to multiply it by this. Now, like I said, there's multiple ways to do these. This isn't necessarily the only way, but whenever I see a term like that, I'm just automatically always going to multiply it by its conjugate. Okay, here's what you're left with. And again, I'm never distributing that. because you'll see why. Because that cosine x always gets taken out. And if you distribute it, you've actually gone in the wrong direction. Now the bottom, because I'm multiplying 1 plus sine times 1 minus sine, that's the difference of squares factored, so I know it's the difference of squares. Like that.
Okay.
Now, I can substitute what for that?
Cosine.
It's cosine squared. The Pythagorean identity.
Okay.
I just didn't want to rewrite the whole thing, okay?
Okay.
Okay. Now, this cosine cancels with that exponent. So I've got that. Now I have common denominators, so I can just operate on the numerator. Well, I got sine x plus 1 minus sine x gives me just 1.
Okay.
And what's the reciprocal relationship there? What's that equal to?
Secant. Yeah, secant.
Part of why these are so helpful in memorizing is because you're looking at what you need to make it equal to. So the moment you get 1 over cosine x, you should see, well, hopefully that's secant x. It needs to be secant x or else I've done something wrong. And that tends to reinforce your memory. So these things really are effective at teaching you your identities.
Okay.
Okay. Now, there's probably a couple of ways I could have done this problem without doing this technique. I could have found a common denominator and added those two, and that actually would have probably worked. I don't know. No need to go back and do it. But there's no way the other method was going to be shorter than 2 steps or 3 steps.
Mm-hmm.
This was actually, let's see, I guess this was 1 step, 2 steps, 3 steps, 4 steps to get to secant x. But I don't think there's another way that's quicker than 4 steps. Not that you'd want to expend energy trying to find it. If you can prove it in 4 steps, that's fine. You know, you're not going to get extra credit by being able to prove it in 3 steps.
Okay.
And I'm guessing that if it took you 17 steps to prove it, as long as you did it and every step was correct, the teacher would give you full credit on it.
Yeah, true, as long as I just show.
As long as you explain every step and you don't make any mistakes, then you'll eventually get to secant x. It could just be a longer way, you know.
Mm-hmm.
But remember this technique. Whenever you're looking at things like 1 minus sine, 1 minus cosine, 1 plus sine, 1 plus cosine, you can always turn those into the difference of perfect squares, which is then replaceable by 1 term. And
Okay.
almost always the same as that term or some power of that. That's why we never distribute that, is because it's always going to get canceled.
Okay.
Yeah, there was actually earlier when I was saying, do you have any that have a 1 plus sine x in them? This was one.
Oh, okay.
Yeah, it's 2 times, one of which has a 1 plus sine x, but that's okay. I didn't need to multiply the whole left side by this. I just needed to multiply this fraction by it.
Okay.
What else?
This one's a little bit different. Tan squared x
Good. I was getting bored.
plus sine squared x plus cosine squared x equals secant
squared x. This is a 1-step problem.
Okay.
What can I replace on the left side? What two?
Sine over cosine.
What two terms can I replace with one term?
Sine over cosine to the tangent.
These two terms are equal to 1. The Pythagorean identity, so I'm going to replace it with 1. And now that, by the Pythagorean identity, is equal to secant squared x. So,
Oh,
2 steps
okay.
instead of 1. 2 steps.
So that's a lot easier.
Yeah, this is actually the shortest one we've done.
Yeah, let's complicated.
I can't think of any that was less than 2 steps.
Yeah, true. That's a lot easier.
Mm-hmm.
Okay, 1 second. I'm just writing it down.
Okay. You will get, like I said, a copy of this file, so you'll be able to see everything we've done. But it won't be until tomorrow because it takes my computer all night long to process those files, and then I'll send it to you. In fact, while I'm thinking about it, give me your email address, Taylor, so that I can send you the link to this recording.
Okay. Are you ready?
Uh-huh.
Taylor Penn.
Taylor's Taylor.
Yes.
PENN. Okay.
Then the number 9
Okay.
at gmail.com.
Wow, there's 8 others out there named Taylor Penn also, I guess, huh?
Yep.
Actually, that's not that uncommon of a name. I'm surprised that you got number 9.
Oh, really?
Yeah, I would have thought there'd have been more of them than that. Okay, tomorrow morning I will send you an email that will give you a link to the recording of this. And it's the same link every time. In other words, save that link on your favorites so that you can always go to it and find your file. There'll be more files than just yours. There's other students also. But your file will have a file name on it that is your first and last initial with the date. So that'll be your file name for this. Is today the 28th? Yeah. That'll be your file name for this session. If you had another session tomorrow, it would be 1029.
Okay, so it's by date.
So when you're looking at that link to find your file, look for this name right here.
Okay.
It won't be hard. You might see a couple of others ahead of you. Depends on what order I upload them. But it's a YouTube file, and which means you can pause it, fast forward it, rewind it, do all the good stuff.
That's good.
Okay, we probably got time for one more if you want to do one more.
Okay, yes. Hold on 1 second. Okay. 1 over sine squared x over cosecant squared x minus 1 equals sine squared x.
Did I write it correct?
The top one, no. Just for the top one, it's just 1 minus sine squared x.
1 minus.
Divided. Yeah. Perfect.
Well, both of these are Pythagorean identities. What's the top one?
Wouldn't that one be cosine?
So I'm just going to cross that out and write cosine squared x there. What's the bottom? The bottom one is that third one that I said you didn't have to memorize. Let's go through that again. Here's the one you need to memorize. But the third one is just the cofunctions of all of these. So what's the third one? It's the cofunction of tangent?
Cotangent.
And what's the cofunction of secant?
Cosecant.
So there's the third identity. So what's cosecant x minus 1 equal to?
Cosecant x minus 1 would be equal to cotangent.
Yeah, so I'll cross that off and replace it with cotangent squared. Okay. And now I've got cosine squared. And instead of cotangent squared, I'm going to use the quotient identity, which is cosine squared over sine squared. And then I'm going to flip and multiply. And when I flip and multiply, I end up with sine squared over cosine to the fourth? No, the cosines cancel, excuse me.
Okay.
I wasn't doing my algebra correct. Yeah, when I flip that and multiply, the cosines cancel and you end up with sine squared. And that's where you need to get to.
Okay.
Okay.
So I just do the reciprocal and then the cosines.
Well, yeah, this was primarily, it was Pythagorean identity, 2 of them. And then it was reciprocal identity, or rather quotient identity. In other words, this was the Pythagorean identity, this was the Pythagorean identity, and this was the quotient identity.
Okay.
And then doing all the algebra reduces this to sine squared x.
So sine squared x.
And that's what was on the right side.
Okay.
Okay. All right.
Yes.
That's pretty good practice for verifying trig identities that are pretty basic and simple. In other words, you just need to know your reciprocal, your quotient, and your Pythagorean identities, and you'll be fine.
Okay.
Okay. All right, Taylor. Well, good luck. And your mom figured out how to schedule appointments by going to my website. I'm actually not positive. I have 2 websites. This is probably the one she found. I'm actually kind of curious on which one she did find, because I don't find too many people in South Florida that find my website. It's not an easy thing to get people to find. Is this what she found, do you know?
Yep, that's it.
That's it. Yeah, that's the one easier to find than Algebra to Calculus Tutor, which is my other.
Let me tell you what I did. I went on YouTube as well.
That's why you found it, because I've got like thousands of videos on YouTube. So
right, I found that and I was impressed. I said I have to find this guy, and then I looked you up, and then I was able to get you. So I was like, all right.
Okay, well, good, good. Yeah, if you go, well, you're familiar with this site then. You know how to schedule on there, and you know how to pay, and both of them work very smoothly on that site.
Okay. What are your best days? What day do you recommend would be best for Taylor?
Well, I'm in Colorado. Kids get out of school here at 3. I generally work from 3 to 9, Colorado time, Mountain time.
Okay. Okay.
So that can be busy. He's certainly welcome to schedule in that time frame like he did tonight. You know, if there's an open spot, he can take it. If you go into my scheduling, it shows my complete availability. And he's welcome to take any spot that's available. One thing that I will add is that you can do half-hour sessions also. So if he has a scheduling problem where his time doesn't work with mine, but he sees a half-hour window that matches with mine, half-hour sessions work pretty good. You get the full concentration from the student in a half hour, and sometimes you don't get that for a full hour. So I tend to tell people that if you're looking for an hour a week I would do 2 half hours a week. You get the same cost, and I think it's a little bit more efficient.
You got it. Okay.
But that's up to you. I mean, he may have a fine attention span, and an hour may not give him any problems at all. So I'll let you decide that on your end as to what to make. You can even make 1.5 hours or 2 hours, but you're going to have to call me or text me to make one of those. My scheduling software doesn't allow online sessions for more than that. I guess you could go in and make an hour session and then follow it with a half hour if you wanted 1.5 hours. That would work.
Okay. All right.
And as far as your balance goes, I'll keep an invoice and send you an invoice whenever there's money owed. And if you've got credit coming, like right now, you've got a $24 credit coming.
Yes. Okay.
So
just keep it, and I'll probably have to put some more money on there because I want Taylor to be autonomous. I'd like for him to know when he needs help and he can schedule it. So I'd like to get him where he's comfortable and confident to do it on his own, and the money will be there. So
sounds good.
What do you think?
Yeah, I agree.
Okay. All right. Sounds like we have a plan.
All right, Taylor. Well, it was nice working with you and meeting you, and hopefully we'll talk again. Incidentally, Taylor, for the next session, if you do schedule one, the only thing I do is text you the meeting ID number. So the home phone number that I called, can it receive texts?
No. Here, he'll give him your cell phone number so he can text you.
Are you ready?
Yeah.
954.
Okay.
729.
Okay.
3445.
Let me repeat that. 954-729-3445.
Correct.
That is the number I will send all my texts to. And like I said, the next time you'll just get a text with a 9-digit number, and you'll know that that's the meeting ID number. And as far as getting into the program, you now have an icon on your desktop that looks like this. This
like a little
flower. Yeah. Is all you have to do is double click that and enter the meeting ID number, and that's all you have to do. In the future. In other words, you don't have to go to join, go to meeting, and download it anymore.
Okay.
Okay?
All right. We might want to talk to him about SAT math before. Would you like to do something with that too?
Yes.
All right. So talk to him. Now's your time before you run up this time. Hurry up.
So, do you have any recommendations for your type of math skills for your SAT practice?
Yeah, what I do a lot of SAT tutoring, and I have like 8 practice tests in my computer, and that's all I do is I go through questions, practice questions, trying to get the student to solve them, and if they can't, I help. So I think that's the best practice for taking the test, is to take practice tests.
Mm-hmm.
Okay.
Okay, so we're gonna.
I'd be happy to work with you on that if you need help.
Okay, thank you.
So let me ask you this: when he schedules, does he type in what type of math he's looking for, or does it matter?
You don't need to. I tutor everything from algebra to calculus BC. So.
Okay. All right. Sounds good. Okay. All right. Thank you so much. We won't keep you. I know we're dragging it out.
Okay.
All right.
Okay.
We'll see you the next time. We'll talk to you soon.
Okay.
Thank you.
Bye. Good night. Bye-bye.